Choosing the wrong table heading format in your Cambridge IGCSE Physics practical is a painful mistake that instantly strips easy marks from your paper. You are literally throwing away points before you even start the math. So lock in your answer right now. Which of these table headings guarantees full marks? Is it A, mass with a lowercase g and parentheses, B, mass/g, or C, mass in grams spelled out? In the high-pressure environment of the exam hall, it's incredibly easy to just write down what feels natural. But Cambridge examiners, they are looking for a highly specific scientific convention. Lock your choice in your head because I'm going to reveal the answer in just a few minutes, and it might actually surprise you. All right, let's get into section 1, the painful mistakes, and exactly why ordinary revision totally fails you here. So here's the harsh truth. Simply memorizing physics formulas, it absolutely will not save you if you don't actually understand the command words the examiner is using. Ordinary revision fails because the alternative to practical paper doesn't just test what you know, it tests how you prove you know it. It's testing your ability to think like a real experimental physicist and communicate your methodology flawlessly. Think about a vague student answer, like, I measured the length. That scores a big, fat 0. Why? Because it completely lacks any evidence of practical skill. But then compare that to a top-band answer, something like, I measured the length using a meter rule with 0.5 millimeter precision. That provides specific scientific reasoning and exact equipment details. And that is exactly what examiners are hunting for when they're grading your papers.
To guarantee those top marks, you've got to use a super specific 4-step framework to structure every single practical investigation response you write. It goes like this. First, identify the concept you're testing. Second, state your evidence or data really clearly. Third, apply scientific reasoning to explain exactly why you're doing it. And fourth, package it all up in the precise examiner wording they expect. You need to memorize this flow. It is literally your ultimate safety net.
Now, in just a moment, I am going to show you the hidden examiner clue that changes your answer entirely, specifically when it comes to handling experimental data that just doesn't fit the trend. But first, you need the framework that makes that specific clue totally obvious. Let's build that foundation step by step so you don't drop a single grade boundary on the easy stuff. Okay, moving on to step 1, selecting apparatus and planning your experiment. Every single high-scoring investigation begins with safely selecting the right techniques and identifying exactly what it is you're testing. Before you even touch a piece of equipment, you have to do a risk assessment. You have to ensure all potential hazards are totally addressed. Then, you choose apparatus that actually has enough precision for your specific experiment. And speaking of precision, think about the number 0.5. You've got to remember that a standard meter rule has a smallest division of 1 millimeter. And because a measurement can realistically be read to about half of a scale division, your reading precision is actually 0.5 millimeters. Dropping that exact number into your planning description, that immediately proves to the examiner that you truly understand the limitations of your apparatus. Now, what's kind of wild is how fundamental yet frequently totally botched variable definitions are. Your experiment plan has to clearly identify them. The independent variable is the one you're actively changing. The dependent variable is the one you are measuring in response. And right alongside those, you have to state exactly which factors you are keeping constant to ensure a fair test. If you forget to list your control variables, your entire experimental plan basically loses all its validity. All right, step 2, making and recording observations. Let's escalate the stakes a bit. This is where you actually gather your data safely and accurately without losing points to really sloppy formatting. And hey, this is exactly where that poll from the beginning of our explainer comes back into play. Let's see if you got it right. The absolutely correct table heading uses the slash format for units. So if you chose mass/g or mass/kg, you totally nailed it. You should never, ever put the units down inside the actual body of the data table. A perfect mark magnet table also maintains consistent significant figures, like writing 1.20 and 2.00, which is appropriate to the precision of the measuring device we just talked about. Writing just 1.2 or 2 without those trailing zeros, that's a common, lazy mistake that examiners actively look for so they can penalize you. On to step 3, interpreting your data and graphs. Once your data is collected perfectly, interpreting it correctly through graphing is your next massive opportunity to secure big points. Look, graphing isn't just about plotting dots on a grid, it's about visually communicating the relationship between the physical quantities you literally just measured. You really need to memorize this checklist because an examiner is actively going to penalize you if you forget to label an axis with both its name and its specific unit, Or if your graph scale is just way too cramped, you've got to use the largest range possible on your grid to accurately represent the overall trend. And remember, you must draw a clean, single line of best fit. No sketchy, hairy lines drawn with multiple pen strokes. And there's a very specific number you need to keep in mind here: 8. 8 is the magic number. If you decide to plot a graph to fulfill the aims of your investigation, you absolutely need at least 8 data points taken over that super large range we just talked about. Why? Well, because fewer than 8 points simply aren't enough to properly establish a reliable relationship or trend line. It is a hard, unbreakable rule.
Which brings us to step 4, evaluating methods and improvements.
So, for the absolute hardest questions on the paper, you have to accept that no experiment is completely flawless, and you have to critically evaluate your own methods. Honestly, this is what separates the average students from the top-tier A-star candidates. You have to identify specific sources of error and suggest exactly how to improve the experiment's accuracy. Let's do a quick challenge. Spot the error in this statement. To improve the experiment, I will just measure more carefully next time. Why is this incredibly common student answer completely useless for securing those final evaluation marks? Think back to our 4-step framework. What are we missing here? Here's the deal. Examiners absolutely despise the phrase human error or measure carefully. It gives them zero scientific reasoning. Nothing. You have to replace it with a highly concrete action. For example, instead of just saying measure more carefully, you need to write something like repeat the measurement of each observation and calculate an average value. Using that specific phrasing proves to the examiner that you know exactly how to minimize random errors and increase the total reliability of your data.
So, mental screenshot time. These are the absolute most common mistakes to watch out for. Missing units in your tables. Rounding your numbers way too early in your calculations. Giving super vague explanations like measure carefully. Making graph axis scale errors. And suggesting weak, non-specific practical improvements. These are literally the fastest ways to drop a whole grade boundary. Avoid these 5 things and your marks are going to skyrocket.
But guys, this brings us to a massive unresolved problem. Listen to this exact quote straight from the Cambridge's 0625 standard. Explain any anomalous results you obtained and how you dealt with them. Okay, but what do you actually write when one of your data points completely ignores your line of best fit? Like when it's just a total glaring outlier?
Seriously, how do you explain those anomalies and evaluate them to squeeze out the maximum possible marks? Because you cannot answer this effectively without understanding the highly specific, incredibly rigid examiner wording required for anomalous results. If you just guess on exam day, you are going to miss out on the crucial top band evaluation marks that actually secure your A-star.
To learn exactly how to conquer those seemingly impossible anomalous data questions, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. And click the explainer on screen right now to master the top band evaluation framework. Because ultimately, doing physics isn't just about recording what happens when everything goes perfectly right. It's about proving you know exactly what to do when everything goes completely wrong. I'll see you in the next explainer.